Hi everyone, welcome to our journey from DSA to Dev. In today's video, we are gonna solve another important question of Leetcode. Uh, it's a very important question because this question can help you solving another complex questions as well. Okay, all right. Let's get started. Uh, let's say you are given a list of integers. You have to find out length of the longest increasing subsequence. Okay, let's understand what it means. So increasing subsequence, so increasing means basically have to find out the numbers in increasing order, right? And subsequence basically you can skip numbers in between. So let's say you start with a sequence 10, you don't have to find out 11 after this. Okay, you can just skip 11, 12, 13 and find out whatever the larger number available in the array. So in this particular example, you will see 101 is the next largest integer, right? Larger integer. Okay. Uh, and after that, after 101, there is no larger integer. So your sequence becomes 10 and 101, right? Okay. Also, if you will observe, I could skip this 101, right? And my answer would have become 10 and 18. All right. So basically, you have to return the length of this longest increasing subsequence. All right. So let's take this example again. Let's say instead of this 18, there was another number 105, right? So in this scenario, what would be the optimal solution? So if we start with 10, we select 101 and then we select 105, correct? And instead of 105, let's say if we had 20, then optimal solution would have become skip this 101 and go for 20. So basically you have to skip this 101 and select 18 as your next number, and then after 18 you have to select 20 as your next number. Okay, all right. But in this question, in this particular example, if you will carefully observe, your increasing sequence is 2, 5, 7 and 18. Okay, so your answer would be 4 in this scenario. You could also take another numbers 2, 3, 7 and then 101, 2, 3, 7 and 1, 18, 2, 5, 7 and 101. So there are multiple options here. You just have to return the length of it. In all these scenarios, the length is 4. Okay, all right. So you observed it here, right? This, what exactly we are doing, we are just skipping numbers. We are checking the possibility of skipping each number. Okay, so we are gonna use this concept for solving this question. Okay, uh, so basically you are checking each possibility, right? So when you are checking each possibilities, what solution comes to your mind? Dynamic programming, right? Basically in dynamic programming you check each possibility. So we are doing the same here. So basically for solving this question you have two approaches. One is your dynamic programming, of course, which seems to be very obvious, and the second solution is by binary search. But in this video we are going to focus on dynamic programming specifically. Okay, all right. So let's talk about the approach, how exactly we are gonna do it. So you will be starting with this number 10. So you have the option either I should select 10 or not. Okay. Um, so you can either skip the 10 and use it. Okay. You will check the both possibilities, and then let's say if you come to 9, you will have another possibility again, whether I should use it or skip it. But if you select 10 as your first number, you can't select 9 as your next sequence, right? So that's also one condition you have to follow here. Okay, so we are just gonna use this possibility of skipping numbers and using it, and we are gonna find out what is the longest sequence. Okay, all right. Let's do it via code. I took the same example here. So we will be using recursion and memoization approach. You can try out with your tabulation approach as well. That would be a good practice for you. Okay, all right. uh, I will write a method. It will return integer, of course, longest sequence. I'll be taking my numbers as in input and my current index. Current index is the index which I want to check whether I should skip it or not. Okay, and your previous index. So whatever my previous sequence was, this value is required because let's say you took 10 as your previous sequence, right? And you have to take any number which is larger than 10, correct? So that's why this previous index is required. Okay, what was the scenario? What we have to check? We have to check if my current index is if my current number at current index is greater than my previous index, correct? Okay, so in this case, what we can call it, we can call it our answer with number included, correct? So if this condition fulfills, that means we can include this number, correct? So let's write the recursion for this. Here we are going to take number. So how exactly I can include this? I will simply move to my next index for checking, right? And simply I will check, instead of previous index I will give it my current index. So hence my current index becomes previous index for the next iteration. Okay, got it? Then I need an answer without including, right? So we will call the same function current index plus 1. We will simply check next number, and instead of current index I will be giving previous index. And also because I'm checking the length, let's say I'll also have to write a base scenario, right? If my current index is greater than equals to, then return 0. So basically we checked our current index is exceeds the length of the array, then we will return 0. Okay, and since we are returning 0, we are not exactly getting an answer, right, anywhere. So first of all, what we are going to do, we are going to return one answer. What we are going to return, we are going to return maximum in both scenarios, right? Okay, so this is not able to read this, so I'll have to write it outside. And I can initialize it with mean value because we are checking the max value here, right? So I will start it with mean value, and I can remove this here. Okay, now let's check this. All right, so this is our answer what we have to return, but currently we are not adding any length anywhere, right? We are just returning 0. So this answer would return 0 in all the cases. So if you will see here, we included our current index, right? So we will add plus 1 here. Okay, it tells us we are including our current index. Okay, also let's start let's check it if what exactly we are getting in the answer. Okay, we will simply call this function with my numbers. My current index will be 0 because I'm starting from the first index, and here I can take minus 1, right? Because 0 is my current index, so previous index has to be less than 0. Okay, and because we are taking minus 1, you will observe this is gonna give me error, correct? Minus 1 is not allowed as index of the array, right? And also this is the base case, so what we can do, we can write if my previous index is minus 1 or this condition fulfills. Okay, in that case I can include my current number. So that was the scenario, right? Because in the first number, when 10 was your first number, you can choose either you should be able to include this or not, because for this 10 number you don't have any initial value to check. You don't have any initial value to check this scenario, correct? Okay, let's try to run this. We should get 4 as an answer, right? Let's see. Okay, yeah, so we are getting 4 as an answer. Let's try another scenario. If we had 20 here, we should get 5 as the maximum answer, right? So you can see it's working properly, but you have to convert it to dynamic programming. So for that, we will simply initialize one array. Here I'm taking a two-dimensional array. Why? Because you can see there are multiple possibilities of current index skipping and including along with previous index. My previous number could be anything, right? So there are two possibilities. So I'm taking two-dimensional array, correct? Okay. Now let's initialize it. I'll simply give it the array's length because we are playing in index, right? So that can't be greater than the length of the array, correct? Yeah, because I'm using it in a static method, right? Okay, let's make it static. All right. So now, uh, what you have to do? You have to simply check uh, if you already have your answer, right? That's what we do in memoization. You have to check if you already have your answer not equals to 0, then return memoization current index and previous index, right? And where exactly you are returning, you just have to store that answer as well. So again, I'm returning it here, so I will store my answer. Okay. All right. Again, let's take one more scenario. For the base case, when your previous index is minus 1, here you are gonna get again index out of bound error, correct? Because minus 1 is again your index. So let's give it plus 1 here. So wherever I will use previous index as index, I will simply add plus 1. Okay. All right. Let's take the case here. Okay. Uh, there is one more scenario which I would like to highlight. It's always better to start with minus 1 because we are dealing with 0. So in some possibilities you might find out that 0 is your answer which is evaluated, but 0 is also your base condition here. Okay, so in this case it's always good to start your initialize your array with minus 1. Okay, let's do that. So I can use arrays.fill method here. I will give it a number I, and I will give it -1. Okay, what does it says? Memoization, right? Yeah. So now you just have to check -1 here. Okay. Now let's run this. All right, we are getting the same answer. Let's remove this and check again. Now we are getting 4 here. Okay, that was all for this question. And because we are taking a two-dimensional array, uh, my possibilities are dependent on two variables, right? Both variables can vary from 0 to n, right? So in that case, my time complexity would be n square. Okay. I hope this part is pretty much clear to you. Please remember to solve this question in tabulation approach also, with tabulation approach also. All right. All right. Thank you guys. Bye bye.